Okay, so for related rates, really related rates are just has to do with word problems with derivatives, okay? Specifically implicit differentiation, which is what we just got through covering. So these are kind of the main steps that you're going to take in these problems. Every time we're going to read the problem, we're going to identify your knowns and unknowns. And you see these little letters here? I'll tell you what those mean in just a second. Second thing is you're going to find a relating equation. Sometimes, like on number 1, they give you the equation. Sometimes you're expected to know it. So like area of a circle, they're not going to give you, I'm not going to give you, the AP test is not going to give you that formula. They're going to expect you to know that. Number 3, differentiate implicitly with respect to time. What have we been differentiating with respect to?
Y.
X. Okay, so remember how we had dy over dx? This is going to be d something, depending on the problem, over dt. Always over dt. Okay? Number 4, we're going to evaluate the derivative with your known values, which just means we're going to plug all the stuff in and figure out our answer. Okay, so here's for these letters. Over here or somewhere on your paper, I want you to write F, W, G, E, or as I like to call it, Fuigi. Okay, Fuigi's kind of weird. That's going to help you remember it, which is good. All right, you're going to forget this phrase, related rates, by the end of the year, but you're going to remember Fuigi. You're going to be like, this is a Fuigi problem. Okay, so the F stands for find. In each problem, you got to figure out, what am I looking for? What am I trying to find? Sometimes they're going to ask it as a question. Sometimes they're going to say, find this, determine this, evaluate this. But find is what you're looking for as your answer. Okay, W is when. All right, in almost every problem, you're going to see the phrase, when, blah, blah, blah. Okay, and that's talking about at a specific time something is happening. And that's what we're going to write there. G stands for any other given information. Okay, so they may give you a rate of change of something that you're given. Okay, and E stands for equation. Like I already said, you may be given the equation, you may have to come up with it. But each time we're going to fill out Fuigi, and then we're going to do steps 3 and 4. Okay, so on number 1, let's just go ahead and write Fuigi. Yep. After we do this a little bit, you may find you don't really like organizing your information this way, and that's okay, but you've got to be able to organize it some way. You don't have to do it the way I'm going to do it, although this is how I'm going to do it each time. Keep in mind that we're going to spend several days on this, so what we're doing today is it's going to get a little bit harder each day. So let's just develop good skills and stay organized some way. Okay, so air is being pumped into a spherical balloon at a rate of 4 pi cubic feet per minute. Determine how fast the radius is changing when the radius is 18 inches. Okay, so what are they asking us to find? So they're asking us how fast is the radius changing? Okay, so they're not asking us to find R, how fast R is changing. So they're asking us to find dr over dt, the derivative of R. How fast is the radius changing? That's dr for radius. Over dt, always going to be over dt. Okay, do you see the word when in there? It's kind of blocked on my page, but right here, when what? When the radius is 18 inches. So notice this is just plain R, because this is not talking about when the radius is changing, but when just what is the radius. And I want you to make sure you put your units here, because we're going to see in a minute that these units in this problem aren't going to match up. We need to recognize that. And the better you are with units, the more, I think the easier this problem is to organize. The units are actually going to help you here. So what else was given? Yeah, so we know we were given this, right? So what does this mean? First of all, it's cubic feet. What's cubic units? Volume per minute. So is this the volume, or is this how fast the volume is changing? How fast the volume is changing. So we're going to say dV over dt. That's one way units really help us out here. So don't just here write 4 pi. Write dv over dt equals 4 pi, and go ahead and even put your units on here. And then they gave us the equation. The more times you write equations, you read it, you hear it, you say it, you're going to know it. Okay, most of the time this volume is given, but you're gonna have this volume memorized. Not today, not tomorrow, but eventually you will, because this volume of a sphere is a pretty popular problem. Okay, our units are not matching up. I have inches and I have feet. Which is easier to change? The inches, definitely. How many feet is 18 inches? 1.5. So we could write that as 1.5 feet. Okay, got to make sure these match up. All right, so up here, what I'm going to do is I'm going to rewrite the formula. And we are going to now do step 3, which is derive both sides. Okay, when you derive both sides, remember how we used to do d over dx? Now we're going to do on these word problems d over dt. T is now our independent variable. And even though t is not part of our formula, it's okay. D over dt, differentiate with respect to time. Okay, so now we get to derive. This is what we've been doing for the past few days, so should be pretty easy. What's the derivative of v? 1. Now we got to go times. Since v is not a t, we have to use chain rule here. Remember how we used to go times dy over dx with implicit? Now we're going to go times dv over dt. So every time you get to a letter that's not t, which will be all of them, you're just going to do d, that letter, over dt. And next time I won't even write the 1 times. It's not hurting anything, but we don't really need it. Okay, we got to derive the right side as well. 3, just use power rule. 3 times 4/3. That's 4 pi r, subtract 1 from the power, 2. Okay, I took a derivative of a letter, of a variable, right? I took derivative of r. So now I got to go times dr over dt. This is an application of chain rule. This is just like when we had dy over dx in our implicit problems the last few days. Okay, so we differentiated. Now we get to plug in. All right, we know that dv over dt is 4 pi. So let's plug 4 pi in on the left. On the right, we got another 4 pi. We got an r squared, so I'm going to put in 1.5 squared. And dr over dt is what I'm actually looking for, so I'm going to rewrite it. Okay, now we got to solve for dr over dt. Algebraically, what do I need to do to get that thing by itself? Divide by 4 pi over 1.5 squared. How else could we solve this equation in our calculator? Because you're going to get to use your calculator on these. Yeah, just use the solve function. Do you remember in the home screen, what do you press to get to the solve function? F2, solve. So you could type that in, solve, parenthesis, type in the equation. In place of dr over dt, probably put an x, and then remember comma x parentheses. So this would be the easiest way to solve. You could definitely solve it by dividing and all that stuff. However you need to, solve for dr over dt. And you should, if you're using your calculator, get 0.4 repeating. If you're in auto mode and you put in a decimal, it's going to give you a decimal answer, which is totally fine. I haven't made a big deal about this because we haven't used our calculators much, but you always have to go to 3 decimal places. On the actual AP test, if you wrote 0.44, you would get this wrong. I don't mean you would get points off for rounding. I mean you might as well have written 27. Okay, rounding error is a big deal on the AP test, so always to 3 decimal places. You do need to write in your units. Yes?
Is the AP test not all multiple choice?
No, it's about half free response, half multiple choice. That's why we do those after parties. However, we're going to work, we got a long time to work our way up to that, but yeah. All right, so this is where a lot of students get mixed up because they're like, okay, I don't know what the units should be. So just think, what are the units on R? Feet. We changed it to feet, right? And then what are the units on time? Minutes, right? So feet per minute. And that's your answer. Just bonus knowledge, just for you. 0.4 repeating is 4/9. 0.5 repeating would be 5/9. 0.8 repeating would be 8/9. That's just for you to know. Extra knowledge for the day. Okay, so let's do another example. So this time what I would like for you to do is read through the problem and see how much a Fuigi you can come up with on your own. Bless you. So everybody's trying to fill in as much as they can right here. Okay, hopefully you got at least a couple of the blanks. Let's go over this together. What are they asking you to find here? Rate of change of the area, so we would write that as D, because rate of change means derivative. So D, what? A for area, exactly. Always over dt. Always. Okay, when what? Side equals 5. You can use any letter you want. If your S's look a lot like 5s, you may want to use X here for side. I'll go ahead and use an S, but you use whatever letter you want. Just be consistent in the problem. Okay, what else was given? What's that 0.4 representing? It's a rate, so it's definitely a d over dt. A rate of what? The side. So ds, right? It says the side of a square is increasing. So that's a positive 0.4. And then go ahead and put your units here. What that does is it helps us make sure that the units line up, and then later on when we get to our answer, it helps us figure out our units. Okay, they didn't give you an equation here. They're assuming that you know area of a square. So what is it?
A equals S squared.
A equals S squared. Again, you could have used X's for these S's. It doesn't really matter. Okay, once you figure out Fuigi, you no longer have to read the problem. That's the nice part about this, is how you can organize the information. Okay, so I have A equals S squared. I'm not ready to plug things in yet. Don't forget, you have to take derivative. D over dt of both sides. Derive with respect to t. So derivative of A is 1 times dA over dt. I'm not going to write that 1 times anymore. And then the right side, what's the derivative of S squared? 2s times, how would we apply chain rule here? Yeah, ds over dt. Always, when you take derivative of a variable, you got to do d, that variable, over dt. Okay, once you get to this stage, you're ready to plug everything in. So on this one, we're actually looking for the left-hand side. And on the right side, we know s is 5, and we know ds over dt is 0.4. This we can do in our heads. 2 times 5 is 10. Move the decimal place over, so that would equal 4. What are the units going to be? Centimeters squared per second. We know that for 2 different reasons. One, they told us. That's the easiest way. The other thing is area is always going to be units squared. Time is going to be the time. So please make sure you get your units right. That's going to be a big thing moving forward. Okay, let's try the next one. So just letting you know, this one steps it up just a little bit. Okay, so let's do this one together. Circumference of a circle increasing at a rate of 2 pi over 5 inches per minute. What is the circumference? Sorry, that's not. When the circumference is 10 pi inches, how fast is the area of the circle increasing in square inches per minute? So what are they asking us to find? A, just A? The rate of change of A, which would be dA over dt. Okay, when what? When the circumference is 10 pi inches. So this is all, I already know this is a weird problem because I have area and circumference. But we'll deal with it. No big deal. Okay, what else was given? This 2 pi over 5 is representing what? The rate of change of circumference. So we write that as dc over dt. And that's going to be 2 pi over 5 inches per minute. The units are good. They're both in inches, so we're good. And because this has circumference and area, let's write both formulas. C equals 2 pi r, A equals pi r squared. These are formulas you should definitely know. Okay, so this is the next big question. Which one of these do we use and derive? We may end up using, we're definitely going to use both of them, okay, but we may only need to derive one of them. We may need to derive both. We have to kind of get into the problem to see. So what I like to do is think, which one do I have to derive? I mean, if I'm looking for dA over dt, I definitely am going to have to derive that formula. And when I get through this, I'm going to get stuck at some point. Okay, and you're not going to know when you're going to get, you're not going to know ahead of time that you're going to get stuck. So I'm going to pretend like I don't know what's about to happen. I'm just going to say dA over dt, derive the area formula. So let's go ahead and do this. A equals pi r squared. And let's derive this with respect to t, the same way we've been doing on the previous problems. So that would be 1 dA over dt equals pi r squared derivative. The 2 would come down to the front and get multiplied to the pi. Their r would go down by 1 in power, and then I would multiply by dr over dt. Every time you take derivative of a letter, you got to go times d that letter over dt every time. Okay, and now I'm looking for dA over dt. That was next to the f. That's what I want. So I'm going to go through, and I don't know r. I think I can find r, okay, but I don't know it yet, so I'm just going to go, I don't know what r is. Okay, and let's just leave a blank there. Okay, dr over dt, I don't know that either. So I'm going to have to go off to the side and figure out what both of these things are, and then I can solve my problem. Okay, so whenever you get stuck like this, if there's information you don't have, go off to the side, think, what else was I given that I didn't know? Okay, so I was given, or sorry, that's not what I meant to say. What else were you given that you haven't used yet? So I was given the C equals 2 pi r formula, and I was given this and this. So I got to use these 3 pieces of information. Finding r is actually a little bit easier, so let's do that one first. So if C equals 10 pi and C equals 2 pi r, then what is just, I mean, I can even set this up. What's r? 5. Were any of you thinking, hey, here's 2 pi r, I should have just put 10 right there, 10 pi? We could have done that. I kind of did it this way because it might not have worked out so easily. Okay, dr over dt is going to take a little bit more doing. Okay, for this one, I'm going to have to actually derive the c equals 2 pi r formula. I didn't know that ahead of time, really. As you do these, you're going to start to recognize it earlier, but you're not going to always know what you need to do. That's okay. Just go through the problem and just say, well, I got to derive c now. So now this one's going to be dc over dt equals 2 pi. Let me write actually what I'm doing. Sorry. I'm deriving both sides. So the derivative of 2 pi r would just be 2 pi times dr over dt. So now plug in 2 pi over 5 equals 2 pi times dr over dt. This is what I'm looking for. This is what I need, and that's what I'm going to plug in over here. So what is dr over dt? You can kind of almost look at this and figure it out. But if not, use your calculator to solve. If 2 pi divided by 5 equals 2 pi times something, what's that something? It's 1/5. Okay, if you couldn't figure that out without a calculator, that's totally fine because you have a calculator here. You can divide by that 2 pi. You can use the solve feature. All right, so we end up getting 1/5. So now I'm ready to actually solve the problem. Yeah, so I end up getting 2 pi. And then my units here for area are going to be inches squared. And my units for time are going to be minutes. You could totally go ahead and multiply 2 times pi and get a decimal here, but then make sure you're accurate to 3 decimal places. Okay, so this was new. We hadn't done one like this yet. Okay, sometimes they make you work for this information. Okay, as you work through these problems, you're going to start to be able to predict that. Okay, but if you don't predict it, it's fine. You just go off to the side and solve a problem. Okay, the next one is kind of like this. So I want you to see how far you can get in this one, number 4. Okay, so on this problem, what are they asking us to find? Yeah, we could use ds, we could use dA. I'm going to use dA, even though it's surface area. It doesn't really make, only because this is going to help me better with my units at the end. If I know A is square units. What about the W? When V equals 36 pi, right? How did you know it wasn't dV over dt?
Would be the rate.
And I didn't say that, right? So how else, looking at the units, how do I know that that's just plain volume and not a rate? The cubed tells me volume, but what's not after millimeters cubed, which is part of rates, per time. I'm kind of really highlighting this because I know from doing this for a while that that's the biggest mistake, is people get mixed up like the variables and then when to do derivative. Okay, what else was given? Yeah, which was dr, because it was how fast the radius is changing. So dr over dt is 5 millimeters per second. So again, I know this is a rate because of the language of the problem, but also because of the units. Per second tells me that that had to be a rate. Okay, in your equation here, you needed 2. You needed one for the volume of a sphere, which is 4/3 pi r cubed. And you needed one for the surface area of a sphere, which is 4 pi r squared. Okay, which one of these do you know for sure you have to derive? Area, because that's what you're looking for. Exactly right. I may need to derive the other one and I may not. Don't do it until you know for sure you need to. So here I have A equals 4 pi r squared, and I need to derive both sides with respect to t. And again, some of you might have used s here, totally fine. Okay, dA over dt. I could have put the 1 times in front. Don't need it, but could have put it there. What's the derivative of 4 pi r squared? 8 pi r times, we took derivative of an r, so dr over dt. You're always going to have a rate on both sides. You're always going to have a derivative on both sides. In a few days, you might have more than 2 of these. There could be multiple ones in the problem. We'll work our way up to that, but you're always going to have at least one on the left and at least one on the right. dA over dt is what I'm looking for, so I'm going to rewrite it. 8 pi. Did they give us r? No. I can find it, but I'm just going to go, hey, figure out what r is in a second. Okay, dr over dt, they did give us. They gave it to us as 5. Oops, sorry. That's not what I meant to do. That space is for r. So once I figure out r, I'm good to go on this problem. So I need to come over here and I need to figure out, okay, what have I not used yet? I haven't used the volume formula or the fact that the volume is 36 pi. Okay, so I'm going to say 36 pi equals 4/3 pi r cubed. I'm just using the formula to figure out r. Okay, again for this, you could use the solve feature in your calculator, or you could just divide by 4/3 pi. Use parentheses if that's what you're going to do. You should get 27 equals r cubed, so r should just equal 3. So my final answer would be dA over dt equals 120 pi. And since A is always square units, I'm going to go millimeters squared per second. And if you multiplied that out to a decimal, just make sure you're accurate to 3 decimal places, to the thousandth. Okay, so this is the first day of related rates. The first 2 we did considerably easier than the last 2, right? It's going to get we're just going to baby step our way up to the more difficult problems. And 5 I'm going to save for another day as review. So